Hello guys, welcome back to Leetcode, and in this video we will see the odd even linked list problem which is from Leetcode day 16 of the May challenge. So let us now look at the problem statement. Given a singly linked list, group all the nodes together followed by the even nodes. Please note here we are talking about the node number and not the value in the nodes. So you should try to do it in place, and the program should run in O1 space complexity as well as order of nodes time complexity. So this is the entire problem. We have a few constraints as well. So as you can look here, the first note is the relative order inside both the even and the odd groups should remain as it was in the input. And the second thing is the first node is considered odd. So indexing basically starts from 1 and goes on. So let us now look at an example in order to get a better understanding. So let us assume that we are given a linked list having 5 nodes. So in this linked list, our index will start from 1 and will go till n, till 5. Okay. Now the head is always pointing to the first node and we are given the head. Now we want to rearrange this entire linked list such that all the odd index nodes should occur first, followed by the even index nodes, and their relative ordering should be same. That is, in the resultant linked list, as you can see, all the odd indexed elements are occurring first, all the even indexed elements are occurring after the odd indexed elements. And you can see that the relative order in this resultant linked list is the same as it was in the original linked list. Like 1 was occurring before 4 and 4 was occurring before 5. So you can see that in the original linked list as well, the order was 1, 4, 5. In the resultant linked list as well, you can see 1, 4, 5 followed by all the even indexed elements, and they are also maintaining their order. So 6 is occurring before 2. In this linked list as well, 6 is occurring before 2. So this you should always keep in mind. Now I hope you got the problem statement. So let us now look at how do we solve this problem. Before solving the problem, we should look at some boundary cases. So the first boundary case says that if we have no nodes, then we will simply return null. Otherwise, if we have only one node, that is the next of this head is equals to null, then we will simply return head. Otherwise, if we have two nodes, then also we do not need to rearrange because the elements will already be arranged, because the first element is odd, second element is even, and you want to put all the odd indexed elements to the left and all the even indexed elements to the right, and this is already in order. So if you have two nodes, then you don't need to do any operation. Only if you have more than two nodes you will do operations. So let us now look at the first method. In order to solve it, I will be showing you two methods. So in this first method, we will solve this problem by using two iterations of this entire linked list. Therefore, the time complexity will still be order of number of nodes. So what we will do is, we will place an end pointer at the end of the linked list. Okay. And then I will also take a counter counting the number of jumps from the head till the end. So in this case, you can see that from 1, if you start jumping one node at a time, then it will take you 4 jumps in order to reach the end node, which is 2. So this count value will actually be important for solving our problem using this first approach, because this will be having different values for even number of nodes and odd number of nodes. So once we have fixed the end at the end of the linked list, then what we need to do is, we can just segregate the odd nodes on the left hand side and segregate the even nodes on the right hand side. So whenever we encounter an even node, we will just append it to the right of this end, and whenever we find an odd node, we will simply skip it. So this is the entire idea for this first approach. How this segregation works? Okay, let me show you. I will take a temp variable, so this will initially be pointing to this head. Now how do we process it? So the end next will now be made to point to this 4. Now this temp next will be made to point to temp next next. And now end next next will be made as equals to null. So these are the 3 steps which are required in order to swap the numbers, that is, make the even index element come to the last. So this will just segregate it. Now after applying this operation, how is our linked list looking? So 1 is now pointing to 5, and 5 is now pointing to 3, 3 is now pointing to 2, and 2 is pointing to 4, and 4 is pointing to null. And where is our end? So our end was pointing to 2 and our temp was pointing to this 1. Now since we have segregated one node to the end, so I will increment temp to temp next, and I will also increment end to end next. Now we will again do the same operation. So what operation did we apply? we will make end next equals to temp next. Okay. After that, temp next will be made equals to temp next next. Okay, so this link is also gone. Now end next next will be made equals to null. So this will make this node 3 come to the end. So after applying this operation as well, our linked list will look like 1, 5, then 2, 4 and 3. Okay, and this is pointing to null. Now where is our end? Our temp was at 5 and our end was basically at 4. Now our second operation is also complete. So when do we actually stop? This all depends on this count value. Whenever we have odd number of nodes, like in this case we have 5 nodes, then how many jumps do we require to reach the end node from the first node? We will require n-1 number of jumps, that is in this case it will be 4 jumps. Now for segregating all the even nodes on the left hand side and odd nodes on the right hand side, we want to do c by 2 number of operations. So c by 2 in this case is equals to 2. Therefore, we have already performed 2 number of operations, and you can see that 1, 5, 2 are basically the odd indexed elements. This is index 1, 3 and 5. They all have come together and all the even index elements are to the right hand side. So this is the entire concept. Now if you have even number of elements, then we will perform c by 2 plus 1 number of operations. And you might be thinking, how did I come with this formula? Actually, I did some dry runs on these examples using even number of elements and odd number of elements. These are the only 2 cases which are possible, and therefore I came up with this formula. So this works for this first method. So let us now look at the code for this method, and then we will see the second approach. So this is the entire code for method 1. Here we will check for the boundary case. After that, I will traverse the entire linked list and place my end pointer to the last node of the linked list. And while traversing, I will also keep counting the number of jumps to reach the last node from the first node. After that, I will check how many jumps did we require. If we require odd number of jumps, that means we have even number of nodes in total. And for even number of nodes, I told you that we will have to do c by 2 plus 1 number of operations. And if we have odd number of nodes, then we will basically do c by 2 number of operations. Now after finding out the number of operations, I will take the temp variable which will be pointing to head, and then I will perform these operations. As I already told you, it is a 3-step operation, and these 2 lines are basically updating the temp and the end value to the next values. So after performing these operations, I will simply return head. That is, we are doing all these operations in place. So let us now look at approach 2. I will take the same example and solve it using approach 2. So this approach 2 says that we will divide this entire linked list into 2 linked lists. One linked list will be having all the elements which are at the even indices, and the other linked list will be having all the elements which are at the odd indices. And then we will simply join them. That is, the tail of the odd indexed element will be pointing to the head of the even indexed element. So this is also a very simple approach. Now how do we apply the operation? So for that, we need to remember the head of the even and odd indexed elements. So this will be odd head and this will be even head. So I will take it as OH and EH. Now after that, I will take 2 pointers, odd and even. Now since we have placed the heads of these 2 linked lists, we will separate the entire linked list into 2 parts. So how do we do it? So look at the steps very carefully. So I will make odd next equals to odd next next. Now I will make even next equals to even next next. Okay. And after that, I will simply update odd with this odd next and even with even next. So this is gone here. Simply this process will keep repeating. Odd next equals to odd next next and even next equals to even next next. So when do we stop? Actually we stop when even is equals to null or even next is equals to null. So in this case you can see that this is even and this is pointing to null. Therefore we stop here. Now you can see that we have successfully divided the linked list. So basically 1 is pointing to 5, 5 is pointing to 2 and 2 is pointing to null. Now we have another linked list which is 4 is pointing to 3, 3 is pointing to null. So these are the 2 linked lists, and we had already saved the heads. This is odd head and this is even head. Now since we have these two heads and we want all the odd indexed elements to the left hand side of the even indexed elements, so the next operation is to make the tail of this odd head point to even head. So how do you do it? After performing all these operations, wherever your odd is pointing to is actually the tail of your odd list. So you will just make odd next is equals to even head. So this is the entire process and you will form this linked list, and this is also an in place operation and you are doing this operation in just a single traversal. So this is also order of n and order of 1 time complexity algorithm. So let us now look at the code for this algorithm. This was also a simple algorithm. First we will do the boundary check. After that I will take 4 variables, even head, odd head pointing to the first and the second nodes, and then odd and even variable which will be traversing in order to separate the linked list into 2 parts. After fixing the heads and assigning the variables, we will do these operations. So at each operation we will check if even is null or even next is null. If this is true, then we will stop. Otherwise we will keep running this algorithm. So as I already showed you, first 2 lines are basically updating the links, and the second 2 lines are basically updating the odd and even values to their next values, so that we can again do this operation iteratively. After doing all the operations, we will successfully divide the linked list into 2 parts, and after dividing it, we will make odd next is equals to even head, because we want the tail of the odd linked list to point to the head of the even linked list, since the even nodes should be present on the right hand side of the odd nodes. After performing all these operations, we will simply return head. So this will be our entire algorithm. I hope you are able to understand it. If you have any other approach or solution in different languages, then please post below so that everyone can take benefit from it. Like and share our video and subscribe to our channel in order to watch more of these programming videos. See you on our next video. Thank you.